All right, this is Professor Pelton. This is Algebra 2, Chapter 6, Section 4. This is the second half of the section, which is on logarithmic functions. The first half was on exponential functions. So you can see I've given you the list again, but however, I've replaced all the exponential functions with logarithmic functions. And this is the same list you've been seeing for chapter to chapter, just replacing f of x with logs. So in chapters 1 through 3, we gave you the generic list, okay, which just used f of x for the function. It had the adding, subtracting, multiplying, dividing, and negatives for the stretching, scaling, and transformations. And the order of transformations doesn't change for logarithms also. Okay. Keep in mind that when doing logarithmic functions in graphing, the inside is inside the parentheses for the log. So adding in the inside, multiplying in the inside, okay, the parentheses dictate the inside. The outside multiplying and the outside adding are your y values, okay, and the negative location inside outside for reflections, okay. All right, so let's do some log examples. So we will do a standard log base 2 as our parent. So this is y equals log base 2 of x. So changing it to its exponential format, that's 2 to the y equals x. We'll do an xy table. Again, I don't really want to graph plugging in x. That's going to be difficult. I can't do that in my head. But I can do plugging in y. So if I plug in -2, I get 1/4. If I plug in -1, I get 1/2. Plug in 0. Anything to the 0 power is 1. 2 to the 1 is 2. And then, of course, 2 to the 2 is 4. So let's see, 1, 0, 2, 1, and 4, 2. Okay, and I'll do one more. 2 to the third power is 8. So there's 4 nice, easy, convenient points. I'm not going to do any higher because they go off the graph, and these ones are fractions, so I'm not going to do those. So that gives us enough points to translate, then transform them around the graph according to what's given. So again, we need to follow the order of transformations in all cases here. So if I look through what I have, the -1 is a translate right, because it's in the inside, so it's counterintuitive. The 2 is a stretch vertically, because that's on the outside, so it affects y. And we have the negative, which is a reflection in the, well, it's on the outside, so it affects y. So if you flip your y value and over the x-axis, if positive y goes to negative y, you went to over the x-axis. So according to the order of transformations, horizontal translations come first, scaling comes second, and then reflections come third. Fourth would be vertical translations, but we don't have any here. Okay, so as a result, this is going to be log base 2 of x minus 1 first. Then we have to do 2 times that second. And then lastly, the reflection of negative of that. Okay, so first I need to move all the coordinates to the right 1 unit, so only the x value changes. So 1, 0 becomes 2, 1. The next coordinate is 2, 2, 0. What am I doing here? Sorry. Get ahead of myself. The next coordinate is 2, 1. Move that to the right one. It becomes 2, 2. The next coordinate in the list is 4, 2. That moves right one and becomes 5, 2. And the last one on the list is 8, 3. 8, 1, 2, 3. Moves right one, it becomes 9, 3. Okay, so each of the points just change the x value to the right plus 1. Oh, I'm sorry, that should be 3, 1, not 2, 2. What am I saying? So I add 1 to x. Okay. All right, so let's move the 2, 0 out of the way also here. Okay, so our original asymptote is x equals 0, because no matter what I do, I can't get to an x value that's 0. It's going to go 1/2, 1/4, 1/8, 1/16, 1/32. It'll get close, but it won't ever get there, right? But if I move this to the translation of 1 to the right, my new asymptote is x equals 1 because of the v minus 1 in the log. So my new graph goes like this. Okay. All right, so we'll take those coordinates there, and we added 1 each of the x values. Now we're going to multiply by 2 vertically, so that only changes the y values. So my first point is 2, 0, but my y value is 0, so times 2 is not going to change anything. My next one is 3, 1. So if I change the y value, it becomes 3, 2. So we multiply the y value by 2. Remember, transformations only affect either the x or the y, not both. So next point is 5, 2. 1, 2, 3, 4, 5, 2. I'm sorry, that's 3, 2. I should have put that on there. 3, 2. All right, so we have 5, 2, 5, 2 now. So that's going to become 5, 4 is our new coordinate, correct? And lastly, our other coordinate is 9, 3. So we have 9, 1, 2, 3. Becomes 9, 6. So we increased our y coordinates by our y values by a multiple of 2, which happens second. So we didn't move left or right, so our asymptote is still x equals 1, that invisible dotted line. Okay. All right, so lastly, we have a reflection, the negative, which is over the x-axis. So the first coordinate is 2, 0. Well, if you are 2, 0, you didn't go over the axis because you're already over it, so nothing moves. The next one is 3, 2. So if you flip over the axes, now you're at 3, negative 2. Okay. The next coordinate we have here is 5, 4. If you go over the axis, it becomes 5, negative 4. 1, 2, 3. And lastly, our coordinate is 9, 6. Over the axes becomes 9, negative 6. All right. And our asymptote didn't change. So I can try to get to 1, but I can't quite get there. It goes up to infinity, and the range up and down is unlimited. All right, pause the video, try the student problem for yourself. All right, for the student problem, we're doing log base 3 as the parent. So that's y equals log base 3 of x, which as an exponent format, 3 to the y equals x. So if we do an xy table, negative 2, negative 1, 0, 1, 2, and 3. So 3 to the negative 2 is 1 over 3 squared, which is 1/9. So that's 1/3. That's 1, 3, 9, and 3 to the third is 27. So 27's off the graph, so we won't do that one. Those are fractions, we won't do those ones. So 1, 0, 3, 1, and 9, 2 are nice 3 convenient whole number points we'll do. Okay, so if we look at the function here, what do we have? We have a vertical translation up, a horizontal translation left, because outside is y, inside is x. And lastly, we have a negative on the outside, which affects y. So that's a reflection in the x-axis, since we're changing the y value. So the order of things is horizontal first, scaling second, which we don't have one in this case, reflections second then, and then lastly is translations up and down. Okay, so log base 3 of x plus the plus 1 must happen first. Then the reflection, and then lastly the vertical translation of adding 2 must happen last. Okay, so it's plus 1, so we're going to go left 1. So 1, 0 becomes 0, 0. 2, 1, I'm sorry, 3, 1, 1, 2, 3, 1 goes left 1 and becomes 2, 1. And then the 9, 2 goes left 1 and becomes 8, 2. All right, so let's erase those old points now. So we went left 1, so our original asymptote is x equals 0, right? That's our asymptote. Because that's the equation of the invisible line, because every value is 0 for x, but all the y's change, right? So now it's x equals -1, and we can make that go like that. Okay, so now we can take each of these and reflect them over the y-axis since we're changing, I'm sorry, over the x-axis since we're changing the y value. If I'm at 0, 0, I'm already at the axis, so nothing's going to change, okay? Let's see, the next point is 2, 1. If I'm at 2, 1 and I go over the x-axis, it becomes 2, -1. And our other point is 8, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 2. Over the x-axis becomes 8, -2. Correct? We'll erase the old points. So flipping over the axes doesn't shift us left or right. So the asymptote still stays the same of x equals -1. We're just going the other way now because we flipped our graph. And lastly, up 2. So if we're at 0, 0 and I go up 2, now I'm at 0, 2. Our other coordinate is 2, -1. If I go up 2, now I'm at 2, 1. And our other coordinate is 8, -2. So 8, -2. And if I go up 2, I get 8, 0. We'll erase our old points now. So we didn't go left or right, so our asymptote stays the same of x equals -1. So the two things that are on the bottom here I can't quite get to are the domain and the range, which is down below. I can't scroll though. So I can get all the way to -1 on the left and positive infinity on the right, but I can't get the -1, so we need parentheses, not brackets. And as far as up and down, it goes forever. And you can look at the table values to prove that. That is the end of part 4.